Okay, lesson 30. Still on the trig graphs, we are making transformations. Your sketches that you have to go and sketch for F, let's make that orange. It's a sin graph. What has happened to this sin graph? Boy or girl? Boy. A boy. What happens to this 2.5? The boy, the y must be multiplied with 2.5. Boy or girl? Also still a boy, not a girl. If it's together with the x, it has to be inside of a bracket if it's plus or minus. Or in other words, 2 times with 2 divided by 2. That's not a girl. That's also a boy. Both of them is boy. So you have to time with 2,5 and you have to minus with the half. Both of them with the y. So what happens to the x of your 5 mother graph points? X's stay the same. So for this x of 0, the y is also 0. Is there a difference if you're going to minus and then time? No. Yes, there is. You have to do order of operations. You have to first time and then minus. There is a difference. So if you take the y that was a 0 and time it with 2,5, it's still going to be 0. Sorry, I'm in the wrong place. 0. And then you minus it with a half. So it becomes negative half. First point. It takes a while. Make sure your first 3 points are exactly right and you can't go wrong further. Second point was at 90. Will the 90 change? Girl didn't do any change here. But the y value was 1. Times with 2,5 is 2,5 minus with a half is 2. So at 90 it's 2. At 180, 0 was the y value times with 2,5 still say 0 minus with a half is now at minus a half. Does it look right? Because remember, sin and cos graphs are quite symmetrical. So these are exactly symmetrical. If you want to start drawing it, see how symmetrical they are. Right? The next one. Now, maybe you can figure it out, but I'd rather want to go for the next point, which was at 270. So at 270, it used to be at negative 1. Times with 2,5 is negative 2,5. Subtract another half. That's negative 3. So it goes way down. What would be the next value? Can you figure it out? 360 and negative a half. You see it? So we've got 0 times 2.5 is still 0, but minus a half will be at half. Negative a half. And make sure your shape looks as nice as you possibly can make it. That was your F graph. Your G graph, this time was a tan graph. So the tan graph, what do you need to know? Asymptotes first, always. And then your points that you know out of your head is 1, 2, 3, 4, 5, 6, 7 of them, which you are going to manipulate and transform. So what happened to this graph? This is a boy or girl? It's a y transformation. So y has to be multiplied by 2. This is a girl. X has to be added by 90. Excellent. So each and every one of your points, you're going to do this. But we start with the asymptotes. Asymptotes has got something to do with the y or the x? X. Its x stays the same all the time with the asymptotes. So if the x's are plus with 90, so will your asymptotes be. So if the asymptote was on 90 and I add 90, where am I now? 180. At 180. Let's make our yellow graph be at 180. Right. Then our next one would have been at 270. It's now going to be at 360. And the previous one would have been at 0. Can you see the pattern go? You can't have it smaller than a bigger, then you're doing something wrong. Do I need to show it? Please do. Some people are very particular in marking in matric papers that you must show all asymptotes, whether it's exponential or logs or whatever the graphs are that you're still going to be doing, and it's on one of the axes. I need to see it. even if the x-axis, you need to show me those dotted lines as well. Some people don't really bother about it as long as it doesn't cut, but you need to show that. Now I know that my little snakes are going to look like this, right? Can a tan graph look like that? How? So this that used to be -1 is now at the top, so it was timed with a negative. So if there's a -2, for instance, here in the front, then the graph wouldn't have been there at the bottom, it would have been at the top. But you do exactly the same thing as you've been taught. Know your mother graphs and do the timing and the plussing and the whatever, and then you'll see it happen. So just so you know that it can also look like that. Then there was a multiplication with a negative to make it look like that. Alright, so then how do I do that for the rest of it? Start off with your first point. Add 0 for x will now be
Plus
90. And the y value that used to be 0 times 2 is still 0. So it's going to be 90, yeah? 0. I always like, for some reason, to do the middle one and then the one to the left and the right. Do the middle one to the left and the right. It doesn't matter. So the 45-degree one will now be at 135. The 45 one will now be at 135. The y value that used to be 1 is now going to be 2. So it's 135 and 2. Take your time. So the next, or the previous one should have been at -45, right? Add 90, where are you now?
45.
At plus 45. And the y value that used to be -1 will now be at -2. And it can't be long there, short there, because then you're doing something wrong. And then make sure you've got your curve, right? For the tan graph, showing that it goes up and going towards the asymptote. When you've got it, you don't need to do the next one. If you made sure that this was right, how can you just copy it to the right? Where will this one be? Right? And 45 to the left and 2 down will bring me there at 2, right? And then as well, on that side, as the positive 2. Curving up, curving down. Don't make horrible things like that. That's not a tan graph. Alright, make sure you've got the curves right. Okay, that's it. How many marks? 6, maybe even 8. Right, make sure you've got the pattern correct. Because now everything follows up on that. What is the amplitude of the orange graph F? Where do you see it? In the front. It's 2,5. What is the amplitude of G? Nope. There isn't one. I'm pointing to the 2 because I want to make you note. It's usually in the front, but if it's tan, it doesn't have an amplitude. Because it goes on until forever, infinity and negative infinity. So there is none. So the period of f, when does the period change? Only if x is? How? How affected? Shifted? Because this is a shift. Does the period change? Only when you take x and you time or divide. Then the period will also be timed and divided. That's the only time. So sin and cos was usually 360 and tan was usually 180. Unless the x has been multiplied, which it hasn't been there, and it hasn't been there, then for the sin graph it will be 360 and for the tan graph it will be 180. Only if the x was multiplied or divided, you'll do the same with the original mother graphs, period. Alright, domain and range. Domain for this one was x goes in between 0 and 360. If I had asked you though for the tan one's domain, was it also the same thing?
Yes, excluding the asymptotes.
But excluding the asymptotes, because you cannot use 360, 180, and 0. And it's fine to rewrite it exactly like that and then just say x cannot be, and then those 3 things. Or exclude, then you've excluded 2 of them and say x isn't 90. There's a different variation from that. The range of G, the yellow one, is the y value on the yellow one. None? Infinity, how do I write that? Ah. Why is every real number? Because it goes to positive infinity and goes down to negative infinity. Why are all the real numbers? Right, all the real numbers. Minimum value of f, -3. Maximum of g, silly question again. Maximum of g is? Maximum. You can't say it's a real number. It's infinity. So, what's the maximum? You can't say the maximum is infinity. There's none. Just the same as asking for amplitude. There's none. Maximum, there's none. Because if you think you've got it there at positive infinity, you're almost there, you're not ever going to get there. There is no maximum. There is no minimum. Okay, now we're estimating our answers because there was some problem on that graph. If man says to you, okay, well, the first one, not a problem. Where are the two graphs? Equal to each other. What are you going to do? It happens there. Now tell me, 135 was that one, right? So this, I jolly well better be less than 135. Are you agreeing with me? So say 130 maybe, for instance. And another place? Okay, now my point was there. It depends on how fat your orange graph was or not. But I'm checking your graph. Not my memo, I'm checking your graph. So your graph, that one was 225. So this was just after 225. Very close. So I'm going to say 230 maybe. Alright. Now we're getting to the part that I actually was talking about just now. If I want to know where the two graphs are above or below each other, I'm going to need to know where's the one above the x-axis and where's the one below the x-axis to make it the one, no, not the either yet. Okay, but let me make my point that I want to make. I'm happy with the tan graph, but I'm not happy with this orange graph. Usually the question will say sketch it, but show me all points of importance. Can I see those turning points clearly? Yep. I see all the other points of importance, but what is not here? The x-intercepts. I'm not seeing the x-intercepts, and that's what I want, and I'm going to need them just now. But how on earth must I know what that x-intercept is? Do I read it off? No, you work it out. How do you work out an x-intercept? By putting y equal to 0. Now remember it was f, so we're going to put the fx equal to 0, 2,5 sin x equal to minus a half. So we're putting the y equal to 0 because we're getting the x-intercept. Now how do I do this? What must I solve? Okay, so how will I do it? Take the half to the other side, then divided by 2,5. I'm just not liking this sum because it's got normal fractions, decimal fractions. It's a little bit here in my card, but anyway. So we're going to divide that and we're going to get an answer on the calculator, please. And then what? Shifts, and to get back to the angle. I've got the ratio, I must get back to the angle. We haven't done that this year yet. So to get back there, you know what x is, you say shifts in of 0, 2, and give me an answer please.
11,54.
11,54. So that means over here, at 11,54, it intersects with the x-axis, and I'm going to need it just now in the next question. But now, what about this one? And you've got to learn a few things still on trig equations, but just thinking about this pattern, it is symmetrical, right? So tell me what that value then must be. 11,5 less than 1/8. Are you agreeing with me? So that little piece there between 0 and 11,5 is the same size as there. So basically you're going to take 180 minus the 11,54 you said, eh? So what's that please? Am I right? 168,46? Calculate please. So now I can do the next question. Well, not this first one. Are you with me everybody?
Yes, ma'am.
That's why they tell you to work out x-intercepts and y-intercepts and turning points, so that when you read off, you've got them already. Okay, missed that one. But at least I'm getting there now. Not needing it here. Where is the orange one under the yellow one? That's what it means if I say F smaller than G. It's where the orange is less than the yellow. Orange under yellow. Orange under yellow. Orange is at the top. Until where? There where they intersected 130. Then it makes a switch. And orange is at the bottom and yellow is at the top. From whatever I said just now, 130, up to where? Up to where? Only there. Because here, the orange one is carrying on its merry way, but the yellow one makes a huge jump from positive infinity to negative infinity. So up to the asymptote, it was yellow at the top, orange at the bottom. Happy on that? Yes. So I have to stop there at 180. Normally, see now I'm at the wrong place. 130 up to 180. And usually we just have to say if it's included, then we just include. And that's wrong. Because there's an asymptote. So you exclude the asymptote. And you must make sure that it's right, otherwise you won't get the mark. Or does it happen again that orange is at the bottom of the yellow one? Where? Because over here, you see this yellow one is way there at the bottom, negative, but it's orange at the top and yellow at the bottom till there. Then it's yellow at the top and orange at the bottom again from the point where they intersect, not 225, 230, whichever you read off, there's not enough space for me here. So from 270 up to 360. Include both of them. 270, but not the asymptote. Are you getting it? So this is what I needed the x-intercepts for. I want the two graphs to be multiplied to give me a negative. That's what this question is always about. It's going to happen in functions as well, parameters itself. If I time two of the graphs and I've got to get a negative, to get a negative, one has got to be positive and one negative. So one above and one below. So where would that be? Can you complete that for me, please, at home? Above and below, you see this little piece here. That little piece there, together with the yellow one, is both below. But then it's above and below up to 90. Are you getting it? You write it complete for tomorrow then. Thank you.